everybody. First of all, I want to thank all of you for being here today. I know it's been a long day, and I appreciate you sticking around for us. I also wanted to thank the kind folks at Adobe and Substance for their amazing set of tools, and secondly, for sponsoring the talk that we have for you today. My name's Steve Henricks, and with me is Ben Nadler. We're both environment artists at ILMxLAB, located in San Francisco. And we're here to talk about how we use Substance in our pipeline to texture cinematic quality VR experiences. But first, a little introduction about ourselves and xLab. So what is xLab? I need to advance the slides. Sorry. No, I got it. No, I don't have it. Sorry. It's been a long day, like I said. So, what is xLab? ILMxLAB is Lucasfilm's immersive entertainment studio based in San Francisco. We focus primarily on pioneering real-time rendered interactive immersive stories on a variety of platforms. We work with world-class directors like Alejandro Inarritu and on IP including Star Wars. We have many collaborators, including Magic Leap, Oculus, and The Void. We're best known for our work in the Oscar-winning Carne y Arena and the VR installation, and critically acclaimed Star Wars: Secrets of the Empire. So about us two geeks. I've been here at xLab for almost 3 years now, and I was lead environment artist on Secrets of the Empire, and then I moved to Vader Immortal. Ben has been with us for almost 2 years now, and he was the lead environment artist on Live CGX, which was our real-time immersive fashion showcase, and Ralph Breaks VR. We both came to xLab from AAA game development and are both driven by a passion for immersive storytelling and the desire to be on the front lines of virtual reality development. Today we're going to dive in depth into two of our experiences I just mentioned, Ralph Breaks VR, which was created in collaboration with Walt Disney Animation Studios, and the Emmy Award nominated Vader Immortal, both of which were built upon our existing pipeline from Secrets of the Empire. We'll discuss how we use Substance Painter, Substance Designer, and Unreal to bring these experiences to life, all within the performance constraints of VR. And with that, I'll hand things over to Ben Nadler, and I'll come back later to talk about Vader Immortal.
All right. Thanks, Steve.
You're welcome, Ben.
My name is Ben Nadler. I'm a senior environment artist at ILMxLAB, and I was lead environment artist on Ralph Breaks VR. When we started development, Secrets of the Empire had just released. We had an established pipeline to build off of, but Ralph had a few differences from Secrets. But before I go any further, let's talk about The Void. So one of our most frequent collaborators has been The Void, which is a location-based VR platform. So how is this different than a VR experience you can go to at your home or experience at home? When guests visit The Void, they don a VR helmet with built-in audio and communications, a haptic vest with feedback devices, and a backpack with a laptop computer. They explore through a compact stage with walls that they can touch that match the environment in virtual reality, and we use various tricks to make it feel like they're moving through a much larger space. The first two projects we created with The Void are Ralph Breaks VR and Secrets of the Empire. While the worlds of Star Wars and Wreck-It Ralph couldn't be any more different, both projects had the same goal, to translate the iconic look of these films into virtual reality. So in Secrets of the Empire, you and up to 3 friends physically navigate through the landscape and corridors of a Star Wars Imperial base, interacting with objects, characters like K2SO from Rogue One, and each other. The visuals are all rendered in real time with Unreal, in stereo at 90 frames per second through virtual reality headsets. Guests also get to feel the heat and wind of the fiery planet Mustafar, feel the vibration of their spaceship, and even smell the ash in the air. The virtual environment is mapped one-to-one over the physical walls, alongside physical props that you can touch and interact with. Combine this with fans, transducers, and even blasters, and you have a truly immersive entertainment experience. So now that you have a basic understanding of The Void, I want to give you a quick recap on the texturing workflow that we had for Secrets. The core functionality of our environment material was built around these principles: a set of shared base materials that we used across most architectural assets at a texel density of 1024 pixels per meter. We then tinted meshes with vertex colors to get some color variation. We layered those meshes with a set of shared tiling grunge textures. Those tiling grunge textures were blended with unique masks on a second UV set. And finally, in Unreal, we had tunable parameters within our material instances to give an artist full control over the surface appearance. First, let's focus on those base materials. Working from reference from the Lucasfilm archives, Steve created 3 tiling textures as the basis for our Imperial environments. All of these were generated procedurally in Substance Designer. When creating these tiling textures, we wanted to make sure we expose as many parameters as possible. This allows us to easily go back and tweak them for other needs, but also gives our CG supervisors and art directors the ability to give feedback and see changes immediately. As you can see here, almost 80% of the Imperial environments used 2 of these base materials. And what you see here is our ILMxLAB basic template in Designer. It outputs not only the maps that we needed to bring into the game engine, but also ones that we needed in Substance Painter that would allow this to be used as a base material. Each project that we have can append to this template and build upon it with additional custom outputs necessary for new workflows. There is an output generator node that sits at the end of the graph. It allows us to do any final processing, such as sharpening or packing grayscale masks into RGB channels in a way that is consistent and flexible. For example, if we change our packing structure down the line, we can edit this one node and then re-export every material and avoid a lot of manual work. So here's the wall module with just the base materials. All right, now let's look at vertex colors. So vertex colors allowed us to add visual variation in a very simple and economic way. It's nothing, I don't know where the presentation went.
I didn't do it.
Oh, okay. All right. Anyway, nothing groundbreaking here, although apparently vertex colors broke the presentation, but we're just using well-known methods to achieve great results. To help us keep a consistent color palette of vertex colors, we used a sort of unknown tool in 3ds Max called Color Clipboard. This allowed us to create and, more importantly, share color palettes. It generates a CCB file that we can put in Perforce, and any artist can open in Max and then share those colors. All right, so now we see that mesh with just vertex color applied. Obviously, it has a little bit more variation than before. All right. With our base material library ready and our vertex colors added to the mesh, now let's focus on the shared grunge textures set. We created these tiled textures to be blended on top of our base materials. So you can see relatively simple designer graphs. We're not doing anything crazy here. To save memory and texture samplers, we packed these 3 grunge maps into a single RGB texture using the RGBA merge node. So you can see here we're adding in some dirt, then scuffs, scratches, edge wear, and then we're on to these unique masks. So the unique masks would control the areas of the asset where the grunge textures would appear. The goal was to automate this process as much as possible to speed up production, but also to ensure consistency among our artists. So the obvious choice for this was Painter. We started by creating our own template called Wall Generic that mirrored the default Unreal template, but we added 4 custom user channels that would contain the unique masks to be exported to the engine. Then we created smart materials to save artists time and give them a consistent starting point. We could also share this with outsourcing partners, and then using these unique maps baked from the mesh and mask generators, we would quickly generate our unique masks. Artists could add paint and fill layers to add additional detail as needed. And now that we have all of our source materials ready, it's time to put it all together in Unreal. So let's take a quick look at this material. Steve made this wall generic master material very early on in the project, and we kept refining it as we were developing our pipeline in Substance. To simplify what you're looking at, we can break it into a few different blocks. As you can see, the different sections that we've looked at already. So Each of these sections had parameters that were exposed for material instances, and those would be what were actually applied to the mesh. Artists would plug in their unique masks and tweak parameters to get the desired look for that architecture piece. Parameters were exposed for things like dirt color, edge wear roughness, and many more. And here is the final result with all those things combined. So this is a very quick abbreviated breakdown. Steve has given a talk previously on this at Substance Days in 2018. So if you're curious about how we textured Secrets of the Empire, you can find that talk on YouTube. And we'll show the slide again at the end of the talk, so if you want to copy the link down. Now that we have that introduction to our pipeline out of the way, let's get into Ralph Breaks VR. So Ralph Breaks VR presented a new, exciting challenge for us. For the first time ever, we were transporting fans into the world of a Walt Disney Animation Studios film. Our previous experiences had focused on photorealistic settings, so this was a huge stylistic change for the team. No more imperial corridors and fiery lava planets. Instead, we were bringing guests into the bright, colorful, eclectic world of Ralph Breaks the Internet. So, you and 3 friends start by meeting Ralph and Vanellope in the Wi-Fi router, where they take you on a train ride to the internet. The internet's teeming with life, from netizens to user avatars to email delivery trucks to pop-up ads. No matter where you look, there's something to see, hear, and feel, with Ralph and Vanellope as your personal tour guides. You go from blasting alien invaders, TIE fighters, and X-Wings in the retro Thunderdome arcade arena to the world's craziest food fight against some enraged bunnies and kitties in the Pancake Milkshake Diner, to an epic boss battle against Bev, an antivirus security system that wants to eradicate you. So, Ralph Breaks the Internet developed a distinct look for the internet itself. It was this Blade Runner megacity with a family-friendly Apple Store sheen. We had to find a way to faithfully reproduce this world with its density scale and millions of users in a way that would meet the performance constraints of running at 90 FPS in stereo. So let's talk about some of these challenges. As with any real-time VR project, we had a lot. Some of them are probably not that surprising. First one is schedule. Any project, you're always going to be on a tight schedule. Here's a picture of me during the last few weeks of production. So we had to release alongside the film, and we knew from the beginning we had to move fast with a solid pipeline that gave us good results. Luckily, we had just shipped a project with one. Tight schedules also mean that you might not get all the resources you'd like for a certain task, so you may need to wear multiple hats and be creative with your approach. Substance and Unreal allowed us as environment artists to find solutions to challenges that might usually be taken on by technical artists or engineers. Second, in any VR project, performance is key to ensure our guests have a comfortable experience. And for many people, this is their first time actually experiencing VR. We need to make sure we hit 90 frames a second at all times. And that's 90 frames per second per eye, which is almost 6 times the resolution of a standard HD console game. So we have to be pretty creative with our content. Then, resolution. In each of the Void's location-based experiences, guests can literally touch the walls of their environment. Models and textures within your space require a higher level of detail, especially since you can place your hands and your face right against it. And as we are inviting people to step into a Disney film in the most immersive way ever, it is critical for our work to be faithful to the Wreck-It Ralph franchise and live up to fans' expectations of that IP. We worked very closely with Walt Disney Animation Studios to ensure we represented the film's characters and world accurately. In fact, many animators who worked on Ralph Breaks the Internet also worked on our experience to bring that authenticity. They were excellent partners, providing concept art, clips from the films, illustration, 3D models, and much more. So, like we did on Secrets of the Empire, we used Substance Painter to create templates, presets, and smart materials to make sure our textures, and most importantly our PBR values, were consistent with the look of the film. The last challenge was quality. On top of this, we were trying to achieve ILMxLAB's stated goal of creating cinematic, immersive entertainment in real time. That's not quite as easy as it might sound. Working closely with our CG supervisor, Pat Conran, technical artist, Ford Hugh, our talented team of environment and character artists, and the rendering engineers in Lucasfilm's Advanced Development Group, We worked hard to bring the look of a Disney film to VR and pushed Unreal to its limits. The image here is our real-time models for Ralph and Vanellope, who look almost identical to their film counterparts thanks to shading improvements we made to the engine for skin, hair, and cloth that brought it to more closely match Disney shaders on the film. And on that note, Ralph Breaks VR is a character-driven experience. The real joy comes from being in the same physical space as these characters and having them interact with you. So we crafted our environments to support that. Considering the density and noise of the internet in the film, this wasn't always easy. It was a delicate balance to fill the world while not detracting from the characters or overwhelming guests with too much visual stimulation. All right, and as I noted before, we'd already built a solid Substance pipeline with both Designer and Painter for Secrets of the Empire, so it was a no-brainer to continue using them on this project. So we can really break the assets in Ralph Breaks VR into a few categories. We had world geometry, which is essentially the meshes that define your playable space. These are objects that you can reach out and touch and are close enough to warrant extra detail. Here's a quick look at one of those pieces in 3ds Max. These models are highly detailed with chamfered edges, weighted normals, and vertex colors, and basically use the same material that we did on Secrets of the Empire that I showed before. In this case, the workflow was basically identical. Second, we had unique props that had unique 0 to 1 texture sets, were baked from high-res sub-D geometry to real-time geometry and textured fully in Substance Painter. It's a pretty typical pipeline, nothing special here. But one of the great things about Painter is how easy it is to make variations quickly. I was able to texture all these donuts and cupcakes in less than an hour, matching to reference from the film. I'm calling dibs on the pink one with sprinkles. Here's what the world geometry and those props look like together. We worked hard to match the film sets 1-to-1, only adding a few additional tables for our fiendish furry friends to hide behind during the food fight. So here's a side-by-side comparison of the final frame in the film to our real-time experience. Obviously, there are some concessions we have to make. We don't have real-time reflections. We can't do dynamic shadowing. It's too expensive, only on the characters. And color grading is quite different in VR, but I'm sure if you kind of, look at it with your eyes squinted a little bit and imagine if we had depth of field and real-time ray tracing in here, we could get almost 1-to-1. Last but not least, buildings. These huge, awe-inspiring skyscrapers that fill your entire view. All right, now we have a quick video to show you the intro to the internet.
Ladies and gentlemen, boils and germs, welcome to the internet!
There it is! Gamer Street, home of the best video game ever!
Ralph! This is so cool! So, what's your plan for sneaking in?
What? I thought you had a plan.
So each building represents a specific website, game, or service. But all those are part of a whole. Collectively, the internet is a character in the film in its own right. The world is not a static asset. It's dynamic and evolving all the time around Ralph and Vanellope, and it was essential that we bring that to VR. So buildings provided a number of challenges for us. First, we needed to achieve a huge density of them that matched the look of the film. Second, they needed to perform well in VR, so we were rendering everything twice at 90 frames a second. Last but not least, we had to create this with only a handful of artists in a few months. So, how did we do it? Well, Walt Disney Animation Studios was kind enough to share dozens of source models for their buildings with us. Some buildings were incredibly specific, like an encyclopedia building with a giant book on top, or branded buildings that we didn't have the rights to include. So we settled on 22 buildings that were generic enough to be reusable and distinct enough to create variation. However, those buildings were provided to us as sub-D models with millions of triangles and textured using Disney's PTEX workflow. So to reduce geometric complexity, we used the geometry as a base and created new low-res buildings within our triangle budget. We then baked a unique normal map from the high-res model to the real-time version, same as we would for a prop. Texture transfer was a little bit more complicated. PTEX is Disney's proprietary texturing workflow that does not require any UV mapping. And if you're interested in learning more about that, you can go to ptex.us. So we had no way of reading PTEX files locally, let alone converting PTEX shaders into textures. So in this regard, we had to start from scratch. Before we even opened Substance Designer, the team poured over frames from the film to analyze the look and feel of the surfaces. While the proportions of characters in the environment are heavily stylized, the actual surface properties are fairly realistic and follow standard PBR conventions. Materials behave and look how you would expect them to in the real world. So using reference images that Disney provided, we broke the building surfaces we would need into categories and then created tiling textures in Designer. Since we needed to be mindful of texture memory, we had to consolidate these into 4 categories. So we had concrete, glass, metal, and finally, tech greeble. It might be hard to see in this picture, but it's under Vanellope's feet. The greeble is sort of the underlying structure of everything that's in the internet. So Designer made it very easy for me to not only create these base materials, but to iterate on them and create new variations based on our reference and feedback from our CG supervisor, Pat Conran. Let's take a look at the concrete textures. So each texture set that we had that defines a material is comprised of 3 textures, a base color, an MRA, and a normal. Now, MRA stands for metallic, roughness, and AO, where each of these is respectively packed into the red, green, and blue channel of a texture. And with my tiling textures created, I reused that wall material from Secrets in the Empire and plugged in my texture sets. And I was able to quickly set up material instances, but the old pipeline was anything but perfect. Needed to take a step back and rethink some things. So, what went wrong? Well, the wall material was designed for assets that were within an arm's reach, like the counter I showed you earlier, not for skyscrapers that were over, hundreds of stories tall. Now, here, you can see that counter, it's very small, and the skyscraper here is actually at 25% scale, just so I could have 2 within the same space and have them still be clear. Also, the wall material was intended for that highly detailed chamfered vertex-weighted geometry, and it didn't even have an input for a unique normal map. So we needed to use the unique normal that was baked from the sub-D assets to compensate for the reduced mesh complexity. Now, to render so many of these buildings too, they had to all be under at least, or at maximum, 4,000 triangles at lot 0. That's less triangles for the whole building than we had used on that counter. And because the internet is so clean, with so many reflective surfaces, the grunge blend features that we had just weren't very useful. Instead, each texture set had some breakup within its own tiling roughness. But by far the biggest issue here was draw calls. The first prototype was 6 draw calls. We had 2 concretes, glass, metal, and the tech greeble, as well as an animated material for our billboard ads. In order to draw hundreds of these buildings at once, we had to reduce that to 2 draw calls, one for the buildings, materials, and one for the ads. So the solution seemed simple to us. We would blend all these textures within one material using a unique mask. Instead of blending parameters for dirt or edgeware like we had done previously, it would blend entire sets of textures, the base color, MRA, and normal, for each of these established categories: tech greeble, concrete, glass, and metal. So I added the additional textures and removed the unnecessary logic for grunge blending. We're down to 1 draw call. At this point, we've diverged quite a bit from that initial wall material. In case you aren't fluent in spaghetti, here's what we're looking at. So you can see we have the 4 different materials, concrete, glass, and greeble, as all of those base material categories that are blended based on the unique mask. Anywhere on the mask that is red will blend in the first texture set. Anywhere that is green will blend in the second, so on and so forth. So, problem solved, right? Our buildings look great. Everything's going well. Gonna hand it back to Steve now, because I'm done. It's perfect. Yeah, here you go. Oh, maybe not. I guess we might have screwed up somewhere. Let's bring our bunny friend back to demonstrate. So we've reduced the number of draw calls, but we've added a lot of texture samples. Penelope's bringing all those textures in right now, baked fresh out of Substance Designer. This is Unreal, can handle a lot of textures, like a lot of textures. One more isn't gonna hurt, right? Let's throw that last normal map in there. Oh, we messed up. So this is the face of a rendering engineer who comes across your wildly unperformant material after it tanks frame rate in your experience and almost causes your lead designer to throw up on himself. So maybe our material wasn't the most performant, but we had at least achieved the quality we were aiming for. We had a blueprint for success, and we just needed to trim the fat. Before I went any further, I duplicated our previous building material to avoid permanently breaking anything. We went from this to this, the final optimized material. They might look similar in complexity, but this one is actually twice as efficient as the other, with far fewer texture samples and complex math operations. But back to our problem, which was pretty straightforward at this point. We simply had too many texture samples, which had cascading performance impacts. More texture samples meant more LERP operations and used more memory. Reducing texture samples would effectively solve the problem we had here. So each base material was comprised of the 3 textures that I mentioned before: base color, MRA, and normal. These were each 2048 by 2048. And on top of that, we had 2 unique textures for each building, the mask and normal map, that were also 2048. So let's look at our concrete textures again. There's a pretty obvious candidate for something we can cut here already, which is our normal map. As you can see, it's mostly flat. What little detail it does add is very subtle. So we were able to remove the normal map from basically every material except for the greeble. And this brought us down to 11 texture samples instead of 14. That's great, but we can do more. So let's look at our MRA texture now. We absolutely need metalness and roughness, but AO also is not really contributing much. So let's remove it. But as you all know, removing a channel from a packed texture is not going to bring down our overall texture samples. So we're not done yet. What we have left is base color, metalness, and roughness. So if we take a closer look at base color, it's mostly monochromatic with a slight gold trim. If we desaturate our base color, which I just did, you might not have even noticed, we can now channel pack this into what was previously our MRA texture. So now we had metalness in red, roughness in green, and base color in blue. So with this new packing scheme determined, Designer made it painless for me to update our Ralph template with our new output texture and re-export everything to Unreal. It took less than 10 minutes to update our entire set of building textures. So now each of our base materials, aside from the greeble, is only 1 texture. We've reduced our texture samples by half, from 14 to 7, and removed 6 LERP operations from the material. But can we do even more? So to go any further, we had to look at how we could optimize the base materials on a case-by-case basis. Once again, there's a pretty obvious candidate here for optimization, the metal layer. Here's the unoptimized texture for metal. Now there actually is quite a bit of information on that left side, but it's completely, you can't even tell. I can see it here, but it's not showing up there. So you can tell base color is pretty useless on here. Metalness is pure white, and the only place we're getting some variation is in the roughness, but even there, it's pretty subtle. So while these subtle details looked really good on a shader ball, they were pretty imperceptible on a large building at a distance. We decided that we could optimize this down to a few simple parameters in the material, like this. So our vector 3 parameter sets our metal color, a vector 1 sets the roughness, and the blue channel of our unique mask already determines what part of the building is metal. So not only did this remove another texture sample, but we actually gave ourselves more control in the end. We can now tint the metal and adjust the roughness per building, creating more variation. So now we're down to 6 texture samples, much fewer LERP operations, and we have a performant material where we haven't really had to sacrifice any quality. So before Steve wrestles the mic away from me, I have a few more images of our world to share with you. I hope you found this glimpse into our pipeline interesting, and that you go and experience Ralph Breaks VR at a Void location near you. In fact, there's 3 within Orange County, so get going, like now. They're putting this on YouTube later. You don't need to listen to his half.
Wait.
Like, get going. Save yourselves. Before I hand this off, special thanks to our outsourcing partners at Elite 3D, who assisted with a large portion of the buildings and props. And last but not least, I really want to thank my incredibly talented environment team, Christy Simone, Brittany Graham, and Ben Hale, as well as everyone else at ILMxLAB who worked on this project over the course of 5 short and incredibly challenging, but all the more rewarding months. With that, I'll hand it to Steve to tell you about Vader Immortal.
Nice. Well, thanks, Ben. So Vader Immortal, a Star Wars VR series, is an original narrative virtual reality adventure that lets audiences step into the role of a smuggler operating near Mustafar, which is the volcanic world that Darth Vader calls home. In typical Star Wars fashion, they'll soon find themselves in the middle of a grand adventure as they are unexpectedly pulled out of hyperspace, and eventually come face to face with the Sith Lord himself. For those of you who haven't seen the trailer, here it is.
You've caused us considerable inconvenience. In a moment, the Lord of this monolith will give you a task. A word of advice. Do not anger Vader.
Now that Vader's found you, he's in reach of enormous power. You must escape.
Grab my hand! I wonder what Vader is after.
It appears Vader has finally found his candidate. And our future is in your hands. Vader is here.
You are the one I've been searching for. Do as I command.
Is there any version of this plan that doesn't end up with us being dead?
So I want to talk to you today about a few ways we use Substance to help bring Vader Immortal to Oculus Quest. The first component of our pipeline is always unique textured objects and props in Substance Painter. Substance Painter was used on every prop in Vader Immortal, and these are just a few, including your player saber. With the ability to use custom shaders in Substance, we were also able to duplicate the same shader we use in the movies or film assets to paint our droid companion Zoe in Substance Painter. One of the things I find really exciting about VR and the AR industry is how rapidly things change, particularly hardware. We began development of Vader Immortal on the Oculus Rift platform, with hardware very similar to that's used in the Void experiences. So naturally, we thought the knowledge we had gained through the production of Secrets of the Empire and Ralph Breaks VR would lead us to success on Vader Immortal. But of course, we were wrong. We're wrong a lot. Sometime around the middle of production, Oculus presented us with the opportunity to push the boundaries of a new platform that would force us to completely rethink the way we are developing Vader Immortal. That platform was the Oculus Quest. For those of you who don't know, the Oculus Quest is the first all-in-one gaming system from Oculus in virtual reality with no wires and no PC. It has inside-out tracking, its own controllers, built-in positional audio, and again, no wires. But what it doesn't have is the same power as a hefty PC built for VR. It's more like the power of this, or rather this, a little bit more beefy version. So needless to say, we had a challenge ahead. We already had a significant amount of content built for Vader Immortal. And we had been using the same pipeline that Ben mentioned in the first part of our talk. The good news is we now had 13.9 milliseconds to play with and only had to run at 72 frames per second instead of 90 on the Quest. The bad news is we had to hit 70 FPS on an Android rendering platform. Not that kind of Android, but that kind of Android. And finally, to make things as difficult as possible, we'd also be making the product not just for Oculus Quest, but for the Rift and Rift S platforms as well. Even though the assets weren't horribly complex, it wasn't going to fly on mobile hardware. So our new challenges were twofold. First, how do we adjust all of our existing content to fit on the mobile budget? And secondly, how do we author new content for both platforms? Luckily, for environment art, we're able to use Substance Painter and Substance Designer to speed up this process. Optimization is, of course, key when you're getting content onto a mobile device. Considering the Quest hadn't been released yet, we really had no established budgets to work with. So we got some tests done with our partners at Ninja Theory and established some baseline numbers. With these rough numbers in hand, we poured over the usual performance suspects: geometry, overdraw, draw calls, and texture sizes. Most of the usual suspects could be handled in Unreal through a slightly modified LOD chain and a few custom tools. With the easy stuff behind us, we turn to the main culprit, material complexity. As Ben mentioned in our previous pipeline, our most frequently used material had a number of texture and vertex color blends. Considering we wanted to avoid repainting all the masks we had made for all our content that drove these blends, we first turned to switching off parameters. Each switch we turned off in our shader reduced complexity, but also reduced the quality of what we were producing. To get things running well on the Quest, we were simply losing too much. A rethink was necessary. The solution was ultimately simplicity. The goal was to maintain all the information from the scratches, scuffs, dirt, edge wear, and all the vertex color, but to compact them into a single operation or two at the most. In comes our cheap, powerful, and unsung hero, Multiply. With Multiply, we can knock out all our blends and put all the detail into a single texture. So our material went from this to this, with many fewer instructions. A quick comparison, our original material on the left and our new optimized material on the right. Not only did we reduce shader complexity, but we actually improved the amount of unique detail we could achieve by not restricting ourselves to color pickers in Unreal. But you may ask, what about all those masks we painted? And the answer was Substance Designer. One of my favorite things about Substance is its versatility. Using Substance, we were able to completely revise our pipeline and revise all our content without losing work. The first step was to convert our tileable diffuse materials to grayscales that were still the base and we would be multiplying color against. So they had to be adjusted to maximize the value of our multiply. And we simply brought these into Designer and revised them as necessary with just a few parameters. Next, we had to deal with the masks we painted. Again, Substance Designer allowed us to automate this process. We brought the masks into Designer, split the channels, and used them as masks, so we could then blend the colors chosen in Unreal into a single multiply texture. We then utilized Designer's baking function to extract the vertex colors from our meshes. Finally, we multiplied this over our tiled base. Now we just had to tackle roughness and ambient occlusion. We began by unpacking the original maps. Again, using our original masks, we reintegrated the roughness changes that we had applied within the original Unreal material. We packed our roughness, ambient occlusion, and edge wear mask into a new texture. With this conversion pipeline, we were able to quickly swap all our assets from the new material and maintain the original look, almost one for one. The use of a tileable base, basically a detailed texture workflow, allowed us to maintain the illusion of a higher resolution texture while still keeping the color variation. So this was great for asset conversion, but we knew we could do it better, specifically when authoring new assets with a multiply workflow in mind. With the previous material, we had parameters in the materials that gave us fine control over the look of our details, scuffs, scratches, and dirt, but we were constrained to a single color for each parameter, or sometimes two. With all this in mind, we quickly went to work building a new Substance Painter template to handle our new output textures. We set up a smart material with a master folder to set to multiply. This allowed our artists to create any combination of layers and subfolders with any blend mode and still be able to see the final result as would appear in Unreal as a multiply. The smart material also allowed artists to paint unique roughness and edge wear maps for each asset, again, improving the look. So in this side-by-side, you can see the leap in quality we achieved by simplifying our material and authoring assets with the multiply material applied. What we lost in terms of pixel density, we gained in variety. The multiply workflow allowed us to use a wide range of color for better variation and a more rich look. We also considerably reduced our material complexity and were able to restore all the detail we had lost on Quest by turning off detail switches in our Unreal materials. In the end, we were able to make a Quest version of Vader Immortal that holds up pretty well on both devices. You can see the Oculus Quest on the left and Rift on the right, I believe. So the last thing I wanted to share with you is a little sculpting workflow that the new improvements in Substance Painter have kind of made more simple, using displacements for sculpting geo. Disclaimer, I just started exploring it, so it's still a little rough and could visually use some polish. So Substance Painter is always being updated, like always, like every 2 weeks. In the last releases, we've seen the introduction of new projection gizmos and projection modes, displacement and tessellation, which is awesome, and compare masks. Displacement workflows have been around for a long time, I'm sure all you know, but Substance Painter brings a new flexibility to this workflow. In Vader Immortal Episode 1, we had a large, expansive cavern with some really sheer cliff walls. Ben Hale, one of our great environment artists, did all his workflow for these rocks in ZBRUSH and Substance Designer. With the new improvements to Substance Painter, I thought maybe we can simplify some of this process and utilize all the great designer work Ben had already done. So I first started the process with a rough piece of geometry, modeled to fit the needs of the scene, and roughly quadded out to support future tessellation. I also made UVs that were in the 0 to 1 UV space. Next, I brought in 4 variations of the cliff wall textures from Ben's graph into Painter to use as displacement maps with the new tessellation and displacement features. In Substance Painter settings, I clicked Enable and adjusted the displacement and tessellation settings. Next, in the texture settings, I added an ambient occlusion layer so I could see the displacement better. Then I added 1 fill layer with my first height and AO maps. Using Substance Painter's TRI-PLANAR functionality and the new gizmos, I was able to easily figure out what tiling worked best for the first set of maps, and you can adjust this stuff on the fly, so it's super intuitive to use. At this point, the cliff was already starting to come along. Next, I baked the rest of the maps. And now I could blend in a second set of textures. Again, I used the gizmos to adjust the tiling and come up with a good result. Next, I used some built-in grunge and procedural masks to get a good combination of these heights. I repeated the process 2 more times with 2 more detail levels. and using some blends to add in some fine detail. For the final step, I added a few simple gradients to give a steep angle to the cliff. In just a few minutes, I had blended height maps to create a great displacement map that could be used in other applications. Substance uses HDR height values, but to use them as displacement maps in some other applications, sometimes a conversion is necessary. Again, Painter makes this super simple. To do that, at export time, all I had to do was add another layer with a pass-through and a levels adjustment to expand the range to its extents. Now our height map is fully grayscale. The last thing to do was make a simple preset to export the map and ensure my output presets were set to 16-bit. So I brought the mixed height map into ZBRUSH, applied it as a displacement map. And this is where I would spend a little bit more time sculpting just to give myself a little bit more unique look. Then I did a high to low poly bake and applied some tileable textures. I also created in Substance using the scan sources and Substance Painter clone tool. If you didn't know it, Substance Painter comes with a great sample that helps you make tileable textures. And I just start with that, and then I layer on a bunch of photo sources and clone things out until I have a great material. And then I brought the mesh into Unreal, applied the material, and that's pretty much it. The main advantages I found in this workflow are that you can preview your displacement without having to do a lot of trial and error in a sculpt. The non-destructive layer system in Painter is perfect for experimentation and blending. You can take any kind of heights and paint them in or paint them out, depending on what you need. Then I found another advantage when I decided that I needed to make a mesh skirt at the top of the cliff edge. With Substance, all I had to do was re-import my new mesh into the Cliff Painter file and instance the layers I already had from the original to the new piece. With Substance, Again, I had a result in just minutes. And this method gave me a relatively seamless transition, even on parts with completely different UV layouts. It was automatic. As you've seen, there's a lot of room for improvement with this method, but there are a million ways to do things, and some of you might wonder why I even went this route. But personally, I find it exciting when tools like Substance Painter and Substance Designer continue to evolve, allowing us to experiment and really push the boundaries of what tools we can use on our experiences, which is what we set out to do every day at ILMxLAB. On behalf of Ben Nadler and myself, I would first and foremost like to thank you all for coming today and sitting through this, and to Adobe and our friends developing Substance tools. Please keep up the good work. Thanks also to all the hardworking crew at ILMxLAB who create amazing immersive experiences all the time. And for those of you excited to try out Force Powers in VR, we're hard at work on episode 2 right now. We should probably be there today, but we're not. Here's a look at some concept art that we recently revealed at San Diego Comic-Con. And if you'd like to check out Secrets of the Empire or Ralph Breaks VR while you're here, as Ben mentioned, there are several Void locations nearby. And for those of you who are interested in our previous talk, here's the slide Ben promised. Give you a second with that. Yeah. And last but not least, we're hiring in our office in San Francisco with new offerings being added all the time. So if you're passionate about real-time immersive experiences, we'd love to speak to you. And we're not only hiring for XLab, Lucasfilm, ILM, and ADG are also hiring for positions worldwide, including San Francisco, Vancouver, London, and ILM's newly announced Sydney studio. So please follow us on social media, and thank you so much for coming. I really appreciate it. And we have some time for questions if anybody has any. So. Yeah, that's what I thought.
Hey, so you said part of your optimizations for your master material was reducing the number of texture draw calls as much as possible. So I was a little curious as to why you guys didn't do any alpha packing or 2-channel normals.
With alpha packing, that greatly increases texture memory. So that was one thing we wanted to avoid. With the normals, we just ultimately, we weren't getting enough of a impact visually from having them, so it just made more sense to cut them than to come up with a scheme to keep them.
Awesome, looks great.
Yeah, thank you. Anyone else?
All right.
Well, if you're shy, you can come up afterwards, and we're happy to answer any questions.
For sure. But thanks for attending and thanks for hanging out all this time.
Thank you so
Appreciate it.
much.